Hello, I'm John Manura. This video is part 3 of the video series on the design, the construction, and testing of a fully automated or CNC rose ornamental lathe. In this video I'll be describing the design and construction of this table for the ornamental lathe. I'll be describing how I assembled the system, how I constructed it, and also laminate the surface to give us a nice smooth surface. I'll also describe the assembly of the linear rails and the stepper motors to complete this table assembly. For design of the cabinet for my system, I use the basic design and cabinet measurements developed by John McGill for his MDF Rose engine. However, I will not be installing electronics inside the case. I will be installing all the electronics in a separate metal case, which I will later locate underneath this cabinet table. The details and dimensions for the Rose engine cabinet are listed on the Calvin Tools website, or you can purchase a kit containing all the parts from this website. If you're considering the addition of a Rose ornamental lathe to your shop, I would highly recommend purchasing the parts kit from Calvin Tools. I cut the various components for the case out of MDF using my table saw. I did make some minor adjustments to these dimensions since I had changed the size dimensions for my spindle head. I also later added a front table to support the controller for my rammed rotary tool. I will later laminate the surfaces of these boards with some Formica laminate that I left over from a storeroom utility table that I had made for my wife. My parts all cut and assembled for the main body to support my table for the Rose machine. And these are all 6 inches high out of MDF. And I did create joints at all the connections so everything is fit nice and tight and snug and everything's square. So when I glue it together, everything will be perfectly straight and square. So all these have dados, for all of the various joints. So I'm ready to start gluing this up. So we have to assemble it. I want to glue some of the center pieces first. So let me just get these set up. And I had designed the thing in Fusion, so it's all designed, all ready to go. I'll be using Type-On glue to glue it together, and I'll be stamping with a nailer. I did a dry run setup of all the cut parts, just to make sure that all my cut dimensions were correct and that everything fit together perfectly. The MDF soaks up the glue quite a bit, so I applied a liberal coat of Type-On glue to all the joint surfaces. After assembling each of the jointed pieces, I used my pin nailer to fix the joints together. These nails do not really provide much strength to the joints. They just hold the joints tight together until the glue sets and hardens. I assembled all the remaining pieces together, fixing each piece with the pin nailer until the entire assembly was complete. I then applied glue to all the bottom faces and attached the large 3/4 inch thick MDF base to these joints, once again using the pin nailer to fix the base plate in place. I had previously marked the joint locations on the outside face of the base plate, so I knew exactly where to place the pin nails. After the glue had been set and dried, I used a sander to remove the excess glue off the outside surfaces, and I sanded all these edges so that they were flush with the sides. Well, this base is all glued up and I sanded it, got all the edges nice and straight. And I was debating how to finish this. My first thought was going to paint it, but I had a bunch of this Formica laminate left over from another project, so I decided to go and laminate this with this Formica. So that's the next step. I'll apply using contact cement, then I'll glue up all these surfaces and install this Formica. It'll last a lot longer and look a lot nicer. I cut pieces of Formica for each of the side panels, about 1 inch longer in both directions, for the board to which they will be attached. I next applied contact cement to both the board and the Formica sheet. I use a brush to apply the contact cement. I actually applied 2 coats of the contact cement to the MDF board since it soaked up quite a bit of the first coat. I allowed the contact cement to dry for about 30 minutes until it was dry to my touch. I then carefully placed the Formica sheet onto the case using my table surface as a guide for the bottom surface. I then used a roller to roll out the Formica sheet to assure a good joint between the Formica and the side panel. I then used a small router with a laminate roller bit to cut off the excess Formica and achieve perfect edges on the Formica on both the top and side edges of the panel. I repeated this process for the remaining side panels of this case. I also sanded the corners of the Formica edges to remove any burrs that were left on the edge by the router. And this completes the basic construction of the table for the Automated Rose ornamental lathe. I'm using the OpenBuild's linear rails for this system, but I'm making a few modifications. Number one, the mounting plates for these stepper motors are really designed for like a NEMA 17 motor, and I'm using NEMA 24 stepper motors. They're much bigger and stronger. So as a result, I had to redesign and remake these plates. So I designed new plates in my Fusion 360 software. Then I machined these on my mill. A little bit larger plate enabled the mounting of all 4 bolts onto the system. So now we place these plates, make for a much stronger system. The next thing I'm changing is the actual system for the riding of the system on these rails. And the normal system uses these small roller bearings that ride on the inside rail. And I'm replacing that with a new system that uses some larger roller bearings that ride on the outside. And that just gives you more stability in this direction. So that'd be a much better way to mount these plates. And then this will mount onto this rail. And then from there, I designed a new plate for here, which will be a much larger plate to enable the mounting of my tool post. That'll mount on here. And this plate will replace this plate with, again, roller bearings right in the outside of the rail. So that'll be that system there. So that's the plan, is to put that plate on there, put these two plates on here, and put new plates on here. So I need to disassemble the system and then re-put it back together with making these modifications. I began by first removing the 4 screws that hold the front plate onto one of the linear rails. I next removed the bearing and locking washer off the lead screw. I then rotate this lead screw in order to remove the gantry plate from the lead screw. I then began the assembly of the new larger gantry plate. First of all, I gathered all the parts that I needed for this assembly. This included 4 of the roller bearings, 2 offset cams, several spacers, 4 metric screws, nuts, and I'm reusing the anti-backlash nut from the original gantry plate. For additional details on how these parts are assembled and adjusted, please go to the OpenBuild's website, since there is a detailed video on how to install and align the roller bearings onto the gantry plates. After installing and aligning the roller bearings, I then reattached the anti-backlash nut block using the same screws that were removed from the original block. Finally, I screwed the assembly back into the lead screw and inserted the lead screw back into the linear rail. I reinstalled a locking clamp and roller bearing back into the end of the lead screw, and then attached the new front plate onto the end of the linear rail. I used 4 screws to attach this plate to the linear rail. I retightened the locking washer to firmly seat the roller bearing onto the countersink hole on the front plate. I also attached a new adapter coupling, which would join the 8mm lead screw to the shaft on a 10mm shaft of the stepper motor. I then repeated these same steps for the other 2 rails. Next, I attached the X linear rail assembly onto the 2 Z linear rails. I had previously added some nut assemblies into the channels on the X linear rail, and then I used screws to attach the plates on the 2 Z linear rails onto this X linear rail. Finally, I needed to attach the complete rail assembly to the top MDF board on the Automated Rose Ornamental Lathe table. I thought this would be a simple operation, but it was actually quite a challenge. I previously inserted some nut assemblies into the bottom channel on both of the Z linear rails. These nut assemblies will later be used to attach the rail assembly onto this top board using some bolts. I carefully laid out a bolt pattern on the bottom of the top MDF board. I then drilled a series of 1/4-inch diameter holes along this projected path for the mounting screws. I also countersunk these holes so the bolts that I would be using would not protrude above the surface of the MDF board. I then used a series of bolts and with washers to pass through the holes onto the MDF board and screwed them into the nut assemblies in the Z-axis rails. This was a challenge, locating the nut assemblies in the channels in the Z-axis rails so that the MDF board could be clamped in place. It took quite a while, but eventually it was completed. Well, I got the system all assembled now, and I mounted it to the table, and I have some bolts going to the table to mount it to the table. I installed my tool post, and I made a jig here with a pin on it, so I can do some printing of some patterns later. So I'm getting set up for that. And next time I'm installing the stepper motors. I installed the one on the x-axis. Now I got to install the two on the z-axis. The installation of the stepper motors is actually quite simple. The shaft on the stepper motor is inserted into the adapter coupling on the linear rail. Some short spacers are placed between the stepper motor and the linear rail front plate to accurately space the stepper motor. Screws are then used to attach the stepper motor to the front plate on the linear rail. The set screw in the adapter coupling is then tightened to join the stepper motor shaft to the lead screw on the linear rail. Okay, I do have some software installed, which I'll be describing some more in the next video. Let me just show some of the operation here. Okay, first of all, X. And then the Z. After the linear rail system design was complete, I went through some initial testing and I discovered a few problems that will need to be corrected. The first issue that I determined is that I needed longer rails for both the Z and the X-axis. And particularly the X-axis rail was not long enough, especially since I wanted to cut on both sides of center on the spindle. Therefore I ordered some longer C-beam channels from Open Builds to correct this problem. The second problem that occurred is that the distance from the top of the X-axis channel beam was too close to the spindle. When I added a chuck to the spindle, the X-axis channel beam barely cleared the side of the chuck. Also, I would not be able to use my 6-inch diameter chuck or cut cylinder boards larger than 8 inches in diameter. This was not acceptable. I determined that there were 3 ways to correct this problem. The first option was to remake the entire base table that I described at the beginning of this video. This table was made with 6-inch high MDF boards for the assembly. If these boards had been 4 inches in height, the system would have been perfect. I saw no easy way to accurately cut down the height of the table, and I did not want to go down the road of remaking the entire table assembly. However, making a shorter height table may be an option in the future. The second option was to raise the position height of the spindle header assembly. Simply putting a spacer block under the spindle assembly would raise the height of the spindle. The third option is to remove the base board to which the linear rails were attached and just mount the linear rail system directly to the tabletop of the case. I decided to use both of these last 2 options. So I remade the entire linear rail system using the new longer linear rails on both the X and the Z axis and mounted this linear rail system directly to the tabletop. This increased the distance between the X rail top and the spindle by 3/4 of an inch. I also added a 3/4 inch MDF board spacer under the spindle header assembly. I also had to make a space adapter plate for the AXA tool post to make it for the additional height required since I had lowered the position height of the linear rail system assembly. The combination of both of these 2 changes increased the distance between the spindle and X linear rail top by 1.5 inches, which is sufficient for my applications. With this change, I'm now able to use my 6-inch chuck, and I can turn cylinder boards up to 12 inches in diameter. If I ever want to turn a larger diameter board, I would just need to add an additional spacer under the spindle header assembly. I also wrote a program to control the manual operation of the X and Z axis positions. In a previous video, I showed this previous menu for the control of the spindle motor, and this control is for the control of the X and Z positions. I have a chart here where I can move the spindle up, down, left, or right. I have controls here to set the speed of motion, and this speed is in inches per minute. And this part on the left here is to set the home position. This is much like using a CNC mill, where once you get the position set for the X or Z axis, you can set that position to 0 and use that as a home position. So that's what this is for. The screen here contains a chart on the right here, which controls which direction I want my spindle to move. In this case, my speeds are set to 10 inches per minute. And all I do is I press my up button to move it in the forward position, the down button to remove it in the opposite direction, and then to move it in the Z negative position, touch that. To move it in the opposite position, just touch that. And that's simply where you are. And these two systems over here control the speed. I can reset those any time just by pressing it, deleting it, changing it to maybe 15. And now it's changed. And once I get a position set, and I want that to be my home position, you see this shows the actual position of the X and Z systems. And if I want that to be my 0 home position, all I do is press my home position, and now that's my home position. This is much like a CNC system, a CNC mill, where you want to set your home position and use that as a reference point. So now this becomes a reference point for all future movement. This concludes this part 3 of this video series on the Automated Rose Ornamental Lathe. In the next video in this series, I'll be describing the design and assembly electronics console to control the operation of the spindle and the linear rails. In the final video in this series, I will further describe the software that I designed to control the operation of the system. If you have any questions, comments, or suggestions on how to improve the system, please leave a comment in this video or drop me an email. The system described so far is still a work in progress, and I'm sure there will be additional design changes, system improvements, and new software changes in the future. Once again, thank you for watching this video.